Hi, welcome to Introduction to Python Programming. This will be our first lecture, which is Unit 1, Part 1 lectures on Python. And our main objective is to go through the basic introduction. For example, what is a hardware, what is a software, how computers store data, and how a program works. Then we talk a little bit about using Python, where we can download Python from, etc. So introduction. As we know, what is a computer? Yeah, we say computers can be programmed that is designed to do any job that a program tells them to do. So most computers normally follows the instruction of a program. So a program is a set of instructions that tells the computer what to do or the task to perform. Then the term programmer, again, is the person or the professional person who can design, create, and also test computer programs. Actually, this term for when we say design, also we have, for example, system analysis. Those are the professionals who can again design the system, analyze the system before the programmers will write the code. So again, the computers can be programmed, and the computer consists of two parts, the hardware and also the software. And we know a computer is any electronic machine that can take an input, a data, then that can process the data, and also it can give us an output, a result. And this output can be stored, so we should have a storage device. And most likely we can also share the results. So in general, we can say that a computer is any electronic device that have an input device, output device, processing device, storage device, and also a device that make it possible to share data with other computers. So first we start with what is a hardware. So the hardware is the physical component that make up the computer. So any physical device of a computer is a hardware. Such as the CPU, the central processing unit, or the storage device, memory, the keyboard, the monitor. A keyboard will be an input device. The monitor will be an output device. So all these are again the hardware devices of a computer. So here we talk about the CPU. The CPU is the central processing unit. And actually we will say that's the main brain of the computer. The processing of any data or any task is done by the CPU. So the CPU have two basic ways of processing things, which is the arithmetic operation, for example, addition, subtraction, multiplication, division, and also modulus. Then we have the logical operation, which is the decision making, whether it's true, a condition is true or false, what to do next. So normally computers make logical decision, true or false. So microprocessors are also the CPUs that are located on the small chips. So we have one chip with 2 or 3 or more microprocessors. The main memory is where we normally store our data temporarily. So a very simple example, when I start my computer and the booting process is going on, what a booting process means is that when we put on our computer power on, our operating system will be loaded into the memory. And any application that are open or are start must be loaded into the memory. So we do most of our work from the memory. But memory again is a temporary storage place, which we call the random access memory or RAM. It's only the data will be in the RAM if only there is power. So anytime the power goes off, again, we lost all the data in the memory or the RAM. We also have the secondary storage devices. So secondary storage device is where we can store our data for permanent, whether the power is on or off, the computer is on or off, or for many years, we store our data permanent. So example can be the hard drive, which is also again, the hardware device, and flash drive, floppy disk. In the olden days, we use floppy disk or flash memory, optical devices such as CD or even DVD. These are all, again, a storage, secondary storage device. We can store data for permanent. Input devices are any device that make it possible for us to enter data into a computer so that this data can be processed by the CPU. So an example of input device can be the keyboard or the mouse, touch screen, scanner. We can scan a document and save the data in the computer. A camera also possible. We can take photos or record a video, and we can input that data into a computer system to be processed. So input device is any device that make it possible for us to input a data. The data can be any type of data. It can be a text data, audio, video, etc. Output device is device normally can display the result after the computer has processed the data. The result can be displayed on our monitor or on a projector. So a projector or a monitor is an output device, or a printer. We can process our data later, we print it. So output device is any device that make it possible to display information from the computer, either on the screen or we print it. Now we go next to the software. So most of all the devices we talk about is the hardware devices. Keyboard, monitor, CPU, memory, they are all hardware, physical components. Software is not a physical component. We use the term intangible, which means actually a software is a code. And normally we have to save this program or the code in an hardware device such as a flash drive or hard drive. So programs are software. So software normally can be saved in a hardware. So we say everything that the computer does is controlled by the software. Again, the software is the code, the instructions for the computer to perform a specific task. We have two general categories of software, the application software and system software. Application software are normally the software that interact with the computer hardware, such as the CPU or even the memory, the printer. For example, when we buy a new printer and I want to connect the printer to my computer, I may have a special software which we call the printer drive or print driver. This printer is a software, it's a system software. This software will interact again with the printer. So without the system software, the printer driver, then it cannot work. So system software, example of a system software be the operating system. The operating system normally interact with most of all the computer hardware components such as the CPU, drive, memory, etc. Now, application software is any software that performs a specific task. So we have example here such as word processing. The word processing software normally we can use it to create documents, or email, web applications. I can use the email or web application, maybe buy things online, whatever tasks I want to do. We have so many different. Also games. Games is also an application software, and a web browser is also. So application software is any software that performs a specific task. And we have thousands of different types of application software. So we talked about the system software already. So program that control and manage the basic operation of a computer. Operating system is a good example. Control the operations of the hardware component. Utility programs such as antivirus software interact with the hardware to create it. Or in the Windows, we have like defragmentation software that will defragment our hardware or delete content in the hardware. These are all utility programs. So how computers store data? Computers only understand zeros and ones. And normally we call that as a machine language. So machine language or binary numeric system consists of only 0 and 1 digits. And we call this a bit. So A bit can be something like an electrical component that can hold positive or negative charge. So when it's on, we say it's 1. When it's off, we say it's 0. This combination of zeros, ones again, make it possible for computer to understand. That's the only language the computer understand. Also, we have a byte. A byte is where we have up to 8 bits. So 8 bits equal to 1 byte. And normally data are stored in a computer system using the byte unit. So for example, when I'm going to buy a flash drive in a computer store, they may tell me one flash drive is, let's say, 1 gigabyte. 1 gigabyte means it can have, giga means billion. So we can store up to 1 billion bytes. It can be digit, character, anything, but what we're trying to say is that 1 byte represents either a character, a digit, or a symbol. Computers normally store data in bytes. And a byte consists of 8 bits. So data stored in a computer must be stored as a binary number, 0, 1s. Also, characters are converted to numeric code stored in memory. And we have the ASCII. This is a standard American standard system for the coding. This is limited to 128 characters. So what we mean by ASCII coding is that, for example, A may represent, lowercase a may represent 66. Uppercase A may represent 87 in ASCII code. So this is a standard code system, international standard code. How a program works. Normally, we say that a CPU designed to perform a simple operations on a pieces of data. For example, we talk about arithmetic operations such as adding, subtracting, multiplying, dividing, or logical decision making, true or false, etc. So to carry out a meaningful calculation, CPU must perform many operations together at the same time. And each brand of a CPU have a different instruction set. Also, a program must be copied from secondary memory to RAM. As we mentioned earlier, random access memory is where we always do our work from. So when I start any program, the program must be loaded to the RAM. And from there, the execution, the data will be sent from the RAM to the CPU. Also, CPU have a special memory called the register. The register that is close to the CPU or is inside the CPU. This is where the data that is being processed is stored for temporary, stored for temporary. Then the CPU also have a special component called the control unit. That's the main component that coordinates the data that flow from the RAM to the CPU, so that we may not have something like underflow. Underflow means we have data to process, but in the register in the CPU, there's no data. Or overflow means we have a lot of data that is come to the CPU, but there's not enough registers or memory to store them to be processed. So CPU, that's why it's called control unit. It's more or less like the coordinator of the CPU processing period of getting the data from RAM to CPU and also back to the RAM after being processed. And normally we have what we call the CPU execution cycle. So the first is we have to fetch the data. So fetch means read the next instruction from memory, that's the RAM, into the CPU. Then we have to decode it. Decode means, as we know, CPU have its own instruction set. So many computer platforms have different type of CPU instruction sets. So the CPU will decode the fetch instruction to determine which operation to perform. After that, it's going to do the execution, which is to perform the operation. So we always use the term machine cycle or CPU cycle execution. Normally, fetch, decode, execute, fetch, decode, execute. So we move from machine language to assembly language. We know the earlier programming languages, let's take us back to like 50, 60, 70 years ago. Most programmers write the program in the machine language, which is 0101. It's very difficult for we human beings to understand or to even to learn it. But later on, assembly language came, which is a little bit far better because it's kind of a form of English. And because computer doesn't understand English or assembly language code, we have a special program called assembler. Assembler would normally translate the assembly language to the machine language for the execution by the CPU. Then next we move to the low-level language, which is close in nature to machine language, called the assembly language. Now we are in the high-level language. High-level language such as Java, C++, C#. These are programs that we can write the code almost in English, source code, but we have either a compiler or interpreter to translate it to machine language so that the CPU can understand to execute it. So in programming language, such as Python also, in this course we are studying Python, we have some few terminology we should know. For example, keywords are normally a predefined words that are used to write a program in high-level language. Keywords are the words that the program understands already. For example, in Python, when I write the word print, everything lowercase print, the interpreter understands that print means to whatever is in the parentheses, we are going to display it on our screen. Now, if I declare a variable and I name it print, all lowercase, I may have an error because the compiler or the interpreter will think print means to print something on the screen. So it's expecting it as a function or a method. So keywords, normally we don't use it to name our identifiers. Identifiers are, for example, the function name, method name, variable names, etc. These are reserved words that the compiler understands. So we have to use it in the way to follow the rules of the program. The next is the operators. We have so many operators, mostly arithmetic operators, addition, subtraction, multiplication, division, and also we have something we call the modulus. Modulus operator normally will give us the remainder of two values that are divided. So for example, if I divide 7 by 2, I know my answer will be what? 3, remainder 1. But if I want only the remainder value, then I'll say 7 modulus 2, and the answer will be 1. Or 7 modulus 3, the answer will still be 1. 7 modulus 7, the answer will be 0. So those are the arithmetic operators. Syntax are just, syntax is the same as like English language. In English language, we have a grammatical rules. There's a rules that we have to follow. For example, I cannot say let's say there, he is, was, is. I mean, you won't understand what I'm saying because each word means something. So we have to put it in order. Maybe I may say there were 5 people, and again, that's grammatically correct in it. So syntax is the same thing. It's a set of rules to be followed when writing program. So if I write a statement and I have to end it with a semicolon, and then that's the rule. Python say, okay, when you write a statement, you don't end it with any, you leave it as it is. That's the rule. Now, when you write a method or a function, you have to indent your code, and that's syntax. So if you don't do it, we get a syntax error. So syntax is just the rules of the language of writing the code. Statement will be individual instruction used in higher level language. For example, I can have a statement that I want to find, let's say even print a statement, computer is easy to understand, or computer program is easy to understand. Or I can write that 2 plus 2 is 20. This is a statement. So a statement will be just an individual instruction. Now, the most important thing in higher level language is compilers and interpreters. These are programs written in high level language. When the program is written in high level language, we have to do what? We have to translate it to a low level, which is machine language, for the computer to understand this. So compilers and interpreters are just, I would say, translators. They will translate the source code to machine language for the computer to understand. So here we say compiler translates high level language program into separate machine language program. Machine language program can be executed at any time and by the CPU. So interpreter is also the same thing, translate and execute instructions in higher level language program. And in Python, we use interpreters. So the difference between compilers and interpreters is that interpreters normally interpret one instruction at a time. Compiler will compile the whole instruction as one unit, and that's the main difference. So source code are the statement that we write in higher level language, such as Python. When I write a Python code, again, we call it a source code. Syntax error means I make the rules, I violate any of the rules of the code or the program language. So for example, I write a Python function and starting with a statement, I didn't indent it. I keep writing. So this would be a syntax error. Even the code is correct, but because I have to indent my instruction at least once, this would be an error. Or I write a function instead of having open a close parenthesis. I just open the parenthesis, write the expression, but I forget to close it. That would be a syntax error. So this is how the process works. We write our high-level language, such as in Python. Here we have a Python language, print hello heartling. This is again a Python language, which means I'm going to display hello heartling in my screen, in my monitor. So after I read, this is almost English. The computer would never understand this. So in Python, we use an interpreter. So in the interpreter, we convert the instruction into machine language. And then the CPU can now understand it, do the processing or the execution. Now, using Python, first we need to install the Python and also configure it. Most of the time when I download or tell students to download their Python, I'll say leave the configuration as default, whatever the system chose you. So one of the items installed is the Python interpreter. Now to install the Python, you can go to, we have so many IDE. IDE stands for Integrated Development Environment. So we have so many IDE to, again, run our Python. So if you go to python.org, you can download the Python interpreter. It comes in two modes. One is interactive mode. It's more or less like a calculator. So you write the code, you press enter, it give you the result. So you don't interpret it. We don't have to write the whole script. But if I want to write a full program, then I will go to the script mode, whereby I'm going to write the whole code. Then later I'm going to interpret it, then execute it. By interactive mode, for example, if I want to find 20 divided by 20.7, I don't want to write the whole code for this. It's only one statement, so I can just use the interactive mode, enter the value, press enter to give me the result. But first thing we do is that we go to python.org. When you go to the website, you see the website looks like this. Then you click on downloads. Now Python runs in Linux, Mac, and also Windows. So you have to select which operating system you are using. Then from there, you just follow after you download it, you install it, you follow the installation wizard steps. In my next video, I'm going to give that instruction how to again download the Python. So in the interactive mode, as we said earlier, when you start the Python in interactive mode, you will see a prompt. The prompt indicating that the interpreter is waiting for a Python statement to be typed. So you can type the statement, then the prompt will reappear again, then you keep typing. Excuse me. So then you keep typing. When you type your statement, press enter, you get your result. And that's a good way to learn a new part of Python, especially if you're a beginner. Then we have the script mode where you can write the whole code. The only thing, when you write the code finish, you have to save the file. And anytime we are saving a Python file, we make sure the extension is So let's say I create a Python program in a script mode to find the sum of two numbers, and I name it program2. So I'll write program2.py to save. That will be the file name. And again, we may do the lab work in our next lectures also. So we'll see the steps. So the idle program environment, this is where we can write the script, which we call the integrated development program. We have the Anaconda is one of the famous one. I like Anaconda in the sense that it has the editor, the interpreter, everything as one unit. The output screen is right in front, and it's one window together divided into 3 parts. Maybe we will go through that. So the idle program environment, which is the integrated development environment, this automatically store when Python language is installed, and it runs in interactive mode also, and it has a built-in tested data with feature designed to help write Python programs. So the idle, basically the whole thing is that you don't have to write for example, I can download the Python interpreter without no ID and no, what we call it, no the interpreter, but no test editor, nothing, the output screen will be. So in this case, I can use the Notepad test editor to write the script. Then I'll go to the command prompt, write the command to run it. But with the IDE, again, everything is integrated. So in this lecture, I just gave introduction to computers, what is hardware, what is a software, RAM, memory, CPU, and also how to install the Python. And in the next lectures, I'm going to show the example on how to install the Python and how to run the first Python program. So again, I'm going to stop here, and I wish everybody the best.